Hello, hello, and welcome again, potentially, to the Hive series on PCB design using KiCAD. My name is Ben, and in this series we've been walking through the PCB design process using KiCAD as our electronics design software. The previous videos, parts 1 through 5, or 5C, went through the design process all the way, resulting in a completed PCB ready for fabrication. The idea of library management was mentioned, as well as in the EDA design flow that I talked about in part 2, as only using project scoped libraries. But when I actually did the design, I ignored it for simplicity and time constraints. In the last video, part 6, we did a project-specific symbol library, and in this video, I'm going to walk you through generating a project-scoped footprint library to package with the rest of your project and keep your work insulated from external changes, and then populating it with some of KiCAD's built-in models. This material, of course, is not required for functional design, but it is good design practice for KiCAD at least, to keep your parts separate from everything else and in a project-level library. Because it's not directly related to the design flow of the previous videos, I'll make no assumptions about your state of knowledge or state of your system or of your knowledge, so I apologize if some of this is repetition for some of you, but let's get started. We're going to start from the project window, the main window here, open the footprint editor, the icon on the right, and this will give you the footprint editor. A lot of this is very similar to the symbol editor if you're familiar with that. All the currently available footprint libraries are on the left. I discussed library availability in the previous video. I think I'll discuss it later on as well. So we're going to be using the flashlight circuit that we developed in the videos 1 through 5C as our parts list. So if you've already made a footprint library during those videos, don't bother to make another one. Otherwise, go ahead and make a new footprint library. We need to do that because, well, for one, that's the point of this video, but also for two, the global libraries are all read-only, so you can't add symbols to them. Make sure to select project for the scope here because we want to minimize our usage of global libraries within our projects. Save the library in your project folder with the same project name probably, and that'll give you a nice empty library. Similar to the symbol library, if you watched video 6, we'll be copying in the global footprints that we need into our new library for use with this project. As I mentioned, we're going to use the flashlight circuit parts. What were those again? Because frankly, I've forgotten. They are these. Don't worry, you do not have to memorize this right now. I'm going to bring this up, or at least I'll tell you which parts you need to copy in. Critical point. Blindly using global footprints can leave you exposed to potential issues if the parts aren't actually standard. They might say they're standard in the data sheet or in the supplier website, but it's really important that you as a designer confirm the dimensions of your parts and your footprints. The failure to do so is at your own risk. Assume and make an ass out of you and me. Don't do this blindly. Now, having said that, a lot of the passive components the symbols are very standard. Those you can definitely use on your own. The IC symbols you want to be a little bit more careful of. That's really where this is coming from. But it's still valid anyway. Always on you to confirm this kind of stuff. So the first thing we're going to do is we're going to start with the 1206 surface mounted packages. So let's go ahead and filter for those on the top left. You'll see a whole bunch of different options, but you'll immediately see, hopefully, a couple under a library called capacitor SMD, which is exactly the one we want. So if you double click on that, you'll see the standard size here. Why are there differences between the 1206C, R, and L and anything else? The answer is the difference is only in terms of labeling, pin numbers, orientation, and the name. But the name is really important, and the reference designator is very important. Actually, it's critical for assembly, so don't choose the wrong one. You might also notice a hand solder version of most of these. What is up with that? If you open up both of them and click on the pad itself, you'll actually see the difference on the size in the bottom left-hand side. The hand solder component is marginally wider, like 0.2 millimeters or so. So it's slightly easier to hand solder, slightly easier, potentially. So you can pick whichever one you want, but you're going to right click on it and go to copy footprint. Not just, there isn't a copy, so just copy footprint. And then you're going to right click the new library and click paste footprint. If you don't see the new library, it means you need to clear the filter box first, because you're currently filtering and the new library doesn't have anything in it. So you'll see it pasted in there. Congratulations. Now you want to copy the 1206R footprint as well. Then you want to copy the 1008L footprint. Use the filter feature again, 1008, and look for the inductor library. The LED can be filtered for by LED, but it doesn't really help to narrow anything down because we don't know the naming standards for through-hole footprints. So instead, we want to go straight to the library itself. There are two LED libraries, the one for SMD, that's LED SMD, or one for through-hole, LED THT. We're going to open the through-hole one. There's still a lot of options, and the naming structure is relatively easy to decipher. Or at least we think so, because D is diameter and W is what exactly? So that's not right. W, I don't know what that is. I assume that's width, but we're not interested in width because we've got a round LED. So this one's closer, but it looks like it's in a horizontal position. You see that? We need the 5mm diameter and a vertical orientation. So this one looks good. Notice there are a few other 5mm options below this. There's -3 for a 3-pin package, which we don't want. There are specific options or labels like that identify different packages, but they might be identical packages. So for instance, the clear or the red top, those are just for 3D model purposes. There's also ones for horizontal orientation, which requires how much space on the PCB it's going to take up. So copy your preferred 5mm LED, the vertical one, the footprint into your library as we have with all the other ones. All right, so we've got these 5 done. Let's see what's left here. We're going to do the diode next. So that's an SOD 128 standard footprint. We're going to copy that standard footprint in. Then you can add that to the library. We're going to filter for the switch, but that gives us too many options again. This is the same problem. Instead, we have to locate that library again. So button switch THT, many different footprints for many different switches of many different types, not just buttons. We're going to hunt through a couple of these. Technically, this is like a switch. I think the switch we're using is considered tactile. So this might be it. But the name doesn't quite have the information I'm looking for, and frankly, it has too much information. So I don't really want to, and I don't want to measure it right here. It's kind of a pain, and frankly, it's too prone to errors. And we can scroll through the library to locate the 6mm options or filter on 6mm and locate the library itself. It's a little bit silly that you can't filter just by the library, but neither here nor there. There are a couple different 6mm options within this library. The variation is only in H. Any guesses what H is? It's for height. Add kind of whichever you'd like to our custom library. Doesn't really matter at this point because we're not worried about the height. That's not a constraint that we're concerned about. If it was, you'd want to pick the correct one. Cool. So that just leaves us with the battery and the IC. And we are actually going to tackle those two in the next 2 videos. Which brings us to the end of part 7a, in which we covered creating a new footprint library and copying in global components. A PDF of this video is available as well, linked in the description and hosted on the Hive's Wiki. In the next video, I will walk through the process of creating a non-standard footprint, like the battery holder, from scratch in KiCAD, and then importing the footprint from the internet instead. I will see you then.